the James Webb Space Telescope has made an astonishing discovery, capturing lights that appear to emanate from a distant point in space, resembling the glow of a city located approximately 4 light-years away. These mysterious lights were detected on Proxima Centauri b, the closest known exoplanet to our solar system. This revelation has reignited the long-standing question of whether extraterrestrial civilizations exist, as these flashes bear a striking resemblance to artificial illumination rather than natural celestial phenomena. Scientists and the public alike have long speculated about the existence of intelligent life beyond Earth, and any evidence hinting at such a possibility has always been met with excitement. The discovery made by the James Webb Space Telescope presents one of the most compelling pieces of evidence yet, as it suggests the existence of structures or even entire cities on Proxima Centauri b. The excitement surrounding this discovery stems from the telescope's ability to observe the exoplanet in unprecedented detail. Proxima Centauri b, a rocky planet orbiting the red dwarf star Proxima Centauri, has long been a subject of interest due to its location within the star's habitable zone. Scientists have theorized that it could possess conditions suitable for life, but the observation of these enigmatic lights takes speculation to a whole new level. Could these luminous patterns indicate the presence of an advanced civilization? If so, how long have these lights been shining, waiting to be detected by our evolving technology? NASA engineers and astronomers are eager to explore these questions further, as the implications of this finding could reshape our understanding of life beyond Earth. David Kipping, an astronomer at Columbia University, has described Proxima Centauri b as a particularly complex planet, unlike most rocky worlds that absorb sunlight and radiate infrared energy. This exoplanet exhibits unique behavior due to its interaction with its parent star. The James Webb Space Telescope's ability to detect infrared wavelengths has been crucial in identifying this anomaly. The telescope's observations provide valuable insight into the atmospheric properties of Proxima Centauri b, allowing scientists to determine whether the planet could support life. Researchers are now planning further studies to examine the planet's atmosphere, investigating its composition and determining whether it contains elements such as oxygen, methane, or water vapor, key indicators of habitability. One of the most intriguing aspects of this discovery is that the telescope can observe Proxima Centauri b at night, detecting even the faintest glimmers of light. This ability is essential for confirming whether the suspected city lights are real or merely natural reflections. The James Webb Space Telescope is designed to detect artificial light if it falls within a narrow frequency band distinct from the broad spectrum of starlight. Proxima Centauri b's unique relationship with its parent star adds another layer of complexity to the investigation. The planet experiences significant temperature fluctuations due to its possible lack of an atmosphere. If Proxima Centauri b does not possess a protective atmosphere, the temperature differences between the day and night sides would be extreme. The day side would become scorching hot, while the night side would plummet to sub-zero temperatures. This drastic thermal variation is of great interest to scientists, as it provides clues about the planet's atmospheric composition and overall conditions. The James Webb Space Telescope's ability to capture thermal emissions allows researchers to analyze Proxima Centauri b's atmosphere in greater detail. Interestingly, the telescope's orbit around Earth coincides with Proxima Centauri b's 11-2-day orbit around its star, enabling precise observations of its day-night cycles. If the planet has an atmosphere, the next step is to analyze its chemical makeup, to determine whether it could support life, detecting the presence of oxygen, water vapor, methane, or other signatures would provide strong evidence of habitable conditions. However, the task is challenging. While the James Webb Space Telescope is highly effective at identifying variations in water vapor, carbon dioxide, and methane, it is not optimized for detecting free oxygen, a crucial element for life as we know it. Nevertheless, it can search for ozone, which could indicate a stable and life-up supporting atmosphere. As scientists continue analyzing the data from the telescope, the search for habitable worlds intensifies. The James Webb Space Telescope can only study a limited number of exoplanets in detail, which is why astronomers eagerly anticipate the launch of future observatories. Ground-based telescopes such as the Extremely Large Telescope YLT set to begin operations in 2028 will provide a more detailed examination of exoplanetary atmospheres. The YT, equipped with advanced imaging technology, is expected to offer clearer data on the potential habitability of distant worlds. Meanwhile, the James Webb Space Telescope remains one of the most critical tools for studying exoplanets. Despite its limitations, the telescope continues to deliver groundbreaking information that enhances our understanding of the cosmos and our place in it. Looking ahead, scientists are developing new technologies to improve the observation of exoplanets. One of the biggest challenges in studying distant planets is the overwhelming brightness of their parent stars. Starlight often outshines the planets, making it difficult to detect the faint light they reflect. To overcome this challenge, researchers are working on innovative techniques to block out starlight while allowing planetary light to be observed. One such technology is the coronagraph, an instrument placed inside a telescope that selectively blocks a star's light while letting planetary light pass through. By shaping light waves carefully, coronagraphs significantly reduce glare and allow for better detection of exoplanets. Another promising technology is the star shade, a giant flower-shaped spacecraft designed to fly information with a telescope positioned tens of thousands of kilometers away. The star shade blocks starlight before it reaches the telescope, ensuring that only the light from exoplanets enters the instrument. This method could be particularly useful in identifying planets within habitable zones where liquid water and potentially life might exist. However, these technologies require an extraordinary level of precision. The star shade, for instance, must be perfectly aligned down to fractions of a millimeter over vast distances for it to function effectively. Additionally, space missions face significant challenges, such as the need for miniaturization, energy efficiency, and durability in harsh space environments. Despite these challenges, the potential benefits of these advancements are immense. Successfully observing and analyzing exoplanetary atmospheres could lead to the detection of biosignatures, chemical indicators of life. The presence of molecules like oxygen, methane, or water vapor in specific ratios could hint at biological processes taking place on distant planets. Scientists are also exploring ways to directly image these exoplanets in greater detail. Future telescopes may be equipped with adaptive optics that compensate for atmospheric distortions, producing sharper images when combined with starlight blocking technologies. These improvements could enable astronomers to not only detect exoplanets but also study their climates and even map their surfaces. The development of next-generation space telescopes represents a significant leap forward in the quest to answer one of humanity's most profound questions: are we alone in the universe? By refining our ability to observe distant planets we move closer to, uncovering the truth about whether life exists beyond Earth. The discoveries made by the James Webb Space Telescope mark an exciting era in space exploration, offering glimpses into worlds that may one day redefine our understanding of the cosmos. As technology advances, the dream of finding extraterrestrial life is becoming increasingly tangible, bringing us closer to unraveling the mysteries of the universe. The discovery of the mysterious lights on Proxima Centauri b has opened up a new frontier in the search for extraterrestrial intelligence. If these lights are indeed artificial, they could indicate the presence of an advanced civilization capable of producing and maintaining sources of illumination. This raises numerous questions about the nature of such a civilization, its technological advancements, and the possible structures that exist on the exoplanet surface. Scientists are currently debating whether the lights could be caused by natural processes such as bioluminescent organisms, or if they are truly artificial in origin. If the latter is proven, it would be the most significant discovery in human history, providing the first evidence that we are not alone in the universe. The James Webb Space Telescope has revolutionized the way we observe exoplanets by offering an unprecedented level of detail in its observations. Unlike previous telescopes, which struggle to capture faint infrared signals, Webb's advanced sensors can detect subtle changes in temperature, light, and chemical composition. This capability is particularly crucial for planets like Proxima Centauri b, where distinguishing between natural and artificial sources of light is a complex challenge. Scientists will need to analyze the spectrum of the detected lights carefully, searching for specific patterns that could indicate artificial origins. For example, on Earth, city lights emit a specific range of wavelengths due to the use of electricity and different lighting technologies. If similar spectral signatures are found on Proxima Centauri b, it could provide compelling evidence of an intelligent civilization. Another major challenge in confirming the nature of the lights is understanding the planet's atmospheric conditions. The presence of an atmosphere could mean that the lights are being scattered or reflected in unexpected ways. If Proxima Centauri b has a thick atmosphere, it might explain the unusual brightness observed. Alternatively, if the planet has little to no atmosphere, the lights would have to be generated by an active source, further supporting the artificial light hypothesis. Future observations will focus on detecting gases like nitrogen, oxygen, and carbon dioxide, which are essential for sustaining life. Scientists will also look for chemical imbalance that might suggest industrial activity, such as excessive levels of methane or other compounds that are typically produced by artificial processes. The possibility of extraterrestrial life has captivated scientists and the public for centuries, but concrete evidence has always remained elusive. The discovery of potential artificial lights on Proxima Centauri b is a breakthrough moment, but it must be rigorously tested and verified before any definitive conclusions can be drawn. As researchers continue to gather data, the scientific community is preparing for the next generation of telescopes, which will be even more capable of analyzing exoplanets in detail. The upcoming extremely large telescope ELT and proposed missions like the Habitable Worlds Observatory will play a critical role in confirming or refuting these findings. These instruments will allow astronomers to capture direct images of exoplanets, analyze their atmospheres, and determine whether they contain the necessary conditions for life. If Proxima Centauri does host intelligent life, it raises profound questions about interstellar communication and the nature of extraterrestrial civilizations would such beings be aware of our existence?